friends, in this video we will discuss about the extension of the cap theorem. Okay, before discuss about the extension of the cap theorem, we will discuss about what is meant by the cap theorem. What is meant by the cap theorem? What does the cap theorem says? Cap theorem says that in a distributed system, if there is a partition tolerance, the system will compromise either availability or consistency. Okay, let's see. Here P means partition tolerance. C means consistency. A means availability. What does the cap theorem says? In the distributed systems, generally we have the partition tolerance. That means we have the partition tolerance. If there is a partition tolerance, whether system will compromise whether consistency or availability. That means if there is a consistency, if there is an availability, means whether we have CP system, whether we have AP system, whether we have CA system. Okay, this system is, this cap system is, this one is does not exist. Does not exist. Whether it will be the compromise, either consistency or availability or partition tolerance, all the three factors will not be satisfied. Okay, generally in the distributed systems we have the partition tolerance. Okay, we have the partition tolerance. So generally in the production systems we have, whether in the CP or AP, in the production distribution systems, there is no chances for the CA. Okay, in the distributed system itself, the network will be distributed into two different networks. Okay, the system will be distributed into two different networks. That means that by default we have a partition tolerance. When the partition tolerance is available automatically, whether we have a CP systems, whether we have AP systems in the production. This is what cap theorem at high level. Now let's see about what the extension of the cap theorem will says. Okay, if we have partition tolerance, right, P we have, okay, partition tolerance. In the production what will happen? Whether it will be, whether we have consistency or availability. That means whether we have CP or whether we have AP. Okay, for example, if there is no partition tolerance, then what will happen? If there is no partition tolerance, that means else case, what we have, whether we have latency. Latency means it shows that latency is less, okay, or consistency. Okay, whether we have latency or consistency. If there is no partition tolerance in the system, it will have either latency or consistency. Okay, this is about the extension of the cap theorem. Extension of the cap theorem denotes that in this way, if we have partition tolerance P, then we have either consistency or availability, okay, or else we have latency or consistency. Extension of the cap theorem is called as PCA ELC theorem. Okay, this is called the extension of the cap theorem. Let's understand in detail about the extension of the cap theorem. Okay, with the examples. Let's take the banking application. Let's take the banking application. Banking application, for example, we have one server. It is a 3-node cluster, 2 servers in one network and 1 server in another network. Okay, these 2 servers will belongs to the network 1. This server belongs to the network 2. Okay, that means we have the partition. What is the partition tolerance? Even one of the network will downs, your application does not get down. It shows that your system will have partition tolerance. Let's assume that this application had a partition tolerance, right? Then what will happen? Let's see, if there is a partition tolerance, whether we have priority to the consistency or availability, right? Let's decide what is the consistency here, what is the availability here. Consistency means, for example, we have a 2 accounts. Okay, we have a 2 accounts. User A account is in network 1. User B account is in network 2. Okay, we need to make a transfer between user A and user B. That is a task. The task is transfer amount between user A and user B. Okay, this is a task. What is a consistency here? Consistency means if transfer happen, we need to take confirmation from both it shows that your system had consistency. Then what the availability will say is, in this case, if transfer happen in both the ends, then only it shows that it is successful. Transfer is successful. If transfer happened, take confirmation from one of the servers, from one of the end, then it is successful. Okay, that means your application here already partition tolerance. There is a partition tolerance. There is a network 1 and network 2. If one of the network goes down, still your application is alive, right? Even you have the servers in both the networks. We have the partition tolerance. Now you need to take the decision here whether we have to compromise in the consistency, whether we have to compromise in the availability. Here consistency denotes that if the transfer of an amount will be happen between the user and user B, okay, if your application takes the confirmation from the user A and also the user B, then only the transformation got successful. It shows that your application is consistency behavior. Availability behavior of your application will states that take confirmation from one of the server is enough. Okay, if it is a banking application, always we should give the priority to the consistency, because if the money transfer got initiated, if network 2 is down, for example, okay, the network 2 is down, then automatically transfer should fail. Okay, if the transfer shows that it is a success, it is not the consistent behavior, right? So that means here what we need to compromise, automatically we need to compromise the availability in the case of banking applications. So here clearly shows that banking applications always gives priority to the consistency, right? If there is a partition tolerance is available, always the banking systems would give the priority to the CP systems, not AP systems. If the banking systems would give priority to the availability, if the transfer happen, that means the money is sending from A, even B account is not get received, it shows that transfer is successful. It is wrong, right? So that's why banking applications always take the confirmation from the both the ends. Here the system will be the consistency. Okay, if there is a partition tolerance, let's assume that there is no partition tolerance. That means what happened? We have two servers, right? That means one network is down. We have only the one network. We have two systems, two servers. Then if application take confirmation from both the servers, it shows that it is a consistency and it have high latency, because we need to take the confirmation from both the servers, right? If application take confirmation from only one server, then it shows that your application has low latency and no consistency. What do you prefer? Let's assume that there is no partition tolerance. That means one of the network goes down. In one network we have two servers. Okay, if the user A transfer the amount, that means if your application is able to take the confirmation from both the servers, it shows that your application has a consistency, but we have high latency. If your application take the consent from the one server, it shows that it has low latency and it doesn't have consistency, right? Always the banking applications would prefer the consistency. Okay, even there is a high latency, it takes the confirmation from both the servers. Yes, the transfer is happened from user A, but user B, it is down. Transfer still it is failure, but it takes the confirmation from both the servers, the transfer is happened from the user A or not. Once network is up, it system already recognized that transfer A happened from between A and B, then automatically it gets received to the transferred to the user B. Okay, this is how the banking applications would work. So in the according to the theorem, if there is a partition tolerance, in the case of banking applications, if there is a partition tolerance, we have only the consistency, or else still the priority to the consistency. This is a system for the banking applications. Okay, let's take the example for the WhatsApp. Let's take for the WhatsApp. Let's discuss about what is meant by the consistency in the case of WhatsApp. Consistency means we able to send messages when both the users are in online. Okay, this shows about the consistency. What is meant by the availability? Availability for the WhatsApp, we able to send messages even one of the user is online, other user will receive later once he comes to online. Okay, this shows that if WhatsApp application maintains consistency, means we are able to send the messages, WhatsApp messages, if both users are in online. It shows that consistency from both the ends, the consistent. Okay, availability means even one user is not in the online, still we able to send the messages, one of the user. Later when other person comes to the online, later he was able to receive the messages. That means it is eventually consistent. Okay, that means the consistency is compromised. That means the application have the availability. Okay, applications have the availability. So according to the CAP theorem, if there is a partition tolerance, let's imagine we have user A in one network and user B in one network server. Okay, user A is connected to the one network of the server and user B connected to the other network of the server. What will happen? Even one of the network will be goes down, still WhatsApp will runs, right? If there is a partition tolerance, WhatsApp need to compromise either consistency or availability. But according to the functionality of the WhatsApp, the consistency is not that much priority here. Here what will be the priority? Availability is a priority. Availability is a priority in the case of the WhatsApps. So WhatsApp is always an AP systems. AP systems. Okay, if one of the network will be goes down, let's imagine one of the network is goes down. In this case we have two servers. Then two factors first comes into the picture. One is latency, second thing is consistency. Here latency means low latency. Okay, don't get confused. Low latency means here latency indicates that it shows that it had a low latency, not high latency. Consistency means we have the consistency between the two servers. At the same time we have high latency because we need to check from both the servers, right? That means how many servers are there in that network. We need to take the confirmation from all the servers, so automatically there is a latency will happen if there is a consistency. Okay, low latency means WhatsApp application take confirmation from one server. Consistency means WhatsApp application take confirmation from both the servers. That means in the case of an WhatsApp, what is a priority? Low latency is a priority. Consistency is not the priority. Okay, low latency is a priority. Consistency is not much priority. That means if there is a partition tolerance, WhatsApp will give a priority to the availability, or else it gives a priority to the low latency. This is what the theorem according to the WhatsApp. Okay, if you take an Amazon, like e-commerce website, Amazon as an example. Amazon, we have the mixed, right? Definitely we have the partition tolerance. Okay, we have the consistency, or else consistency systems where there is a payments. Okay, and if there is a partition tolerance and there is an availability, or else there is a low latency, where in browsing the website, that means product listing. In the case of the product listing, Amazon should give the high priority to the availability than the consistency. Okay, and it also will have the low latency. Even the network will down, it should have the low latency. But in the case of the payment systems, it should always have the consistency than the availability. Payment will be failure, it doesn't matter, but once the payment gets successful, it should be shows the same thing for the both the users. That means both the users means both in the inventory at the same time for the user also, it will be shows the same. Okay, so that's why the payment should be the consistency. Even the network will be the down, it gives a high priority to the consistency than the latency. Okay, I hope you people are understand about this completely extension of the cap theorem. The cap theorem will always shows that if there is a partition tolerance and availability and consistency, either one of the factors should compromised. Especially in the distributed systems, the partition tolerance is always available. That means we should have a compromisation in consistency or availability. For example, if the entire network got failure, what are the two factors are involved? Latency or consistency. Okay, this is what the extension of the cap theorem will say. This is an extension of the cap theorem. If there is no partition tolerance with a single network, then the latency and consistency comes into the picture. Based upon your application functionality, you should give an high priority. For the banking applications, latencies doesn't matter, the consistency is always matter. In the case of WhatsApp, consistency doesn't matter, latency is always matters. It should have low latency if network goes down. Okay, in case of an application like Amazon, we have the mixed cases. Based upon the use cases, the system will be designed. Okay, thank you. Please subscribe. If you like this video, please subscribe to this video. Thank you.